This is a presentation on the educational outreach for the new Stochastic Empirical Loading and Dilution model, SELDM, for highway and urban stormwater analyses. This presentation was presented at the Association for Environmental Engineering and Science Professors Research and Education Conference at the University of Michigan in June of 2017. The project is a collaboration between the U.S. Geological Survey and the Federal Highway Administration. SELDM was developed by the U.S. Geological Survey in cooperation with the Federal Highway Administration and is designed for the analysis of stormwater quality from a site of interest, its upstream basin, and the receiving water downstream of the outfall. It's a tool for estimating the adverse effects of runoff on receiving water and the potential effectiveness of best management practices for reducing those risks. SELDM is a stormwater model designed to estimate storm flows, loads, and concentrations in storm flows from upstream basins, a site of interest such as a highway or an urban area, BMP outfalls, and in the receiving water downstream of the site of interest. SELDM is a stochastic model because it uses Monte Carlo methods to create a sample of events representing combinations of flows, concentrations, and loads. It's an empirical model because it's based on data and statistics rather than just pure theory. You do not have to spend a lot of time calibrating SELDM because it's calibrated by using input statistics calculated from data. The statistics are already calculated and preloaded for ease of use. It's a loading model because it provides storm and annual loads. And it's a dilution model because it calculates the mixing of upstream and highway contributions to indicate chance of exceeding a target concentration value downstream of the outfall. SELDM has been thoroughly reviewed and tested. Engineers, hydrologists, regulators, and environmental specialists from the USGS, the Federal Highway Administration, the US EPA, and the US Fish and Wildlife Service, as well as 15 different state DOTs and the Massachusetts Department of Environmental Protection, have all participated in SELDM beta test processes and/or official model review. SELDM uses a simple mass balance approach to calculate flows, concentrations, and loads by storm and by year. This is a simple schematic diagram showing a highway crossing at a river site. The upstream load for each storm is the product of the stochastic upstream concentration and flow. The highway runoff load is the product of the stochastic concentration and flow from the site of interest, which can be modified by specifying BMP treatment statistics. The downstream load and downstream flow for each storm are the sum of the upstream and highway runoff values. The downstream concentration is calculated by dividing the load by the flow. SELDM uses Monte Carlo methods to generate precipitation, pre-storm flow, and runoff coefficients to generate the storm flows. It generates concentrations either as random variables, dependent variables, or for the upstream basin as transport curves, which are relations between streamflow and concentration. It has a BMP module that generates performance criteria including flow reduction, concentration reduction, and hydrograph extension. The USGS, in cooperation with the Federal Highway Administration, developed and delivered a series of half, 3, and 4-day training classes on SELDM in states across the country for staff from the Federal Highway Administration, state DOTs, federal and state regulatory agencies, and resource management agencies. Most SELDM class attendees said they needed researchers, employees, consultants, and regulators who understand the unique challenges involved in managing and mitigating stormwater runoff and water quality for transportation projects. Efforts to build an expert user base of working professionals are hampered by the nature of adult learners, distractions of their current job, and the need to compress a semester of material into a one-week class. Therefore, outreach to colleges and universities is needed to train upcoming students and to inform future research efforts. The SELDM project has developed a variety of teaching materials to make training and lectures easy to adopt. Materials currently developed include 44 lectures and training PowerPoints, 17 exercises, and 5 case studies. It is recognized that developing courses and material takes a significant amount of time and often hampers the adoption of new material in academia. It can take several hours to develop 1 hour of class time. Adoption of SELDM training materials will help civil and environmental engineering professors develop new curricula that include recent research focused on highway hydrology. This information will help prepare students to meet DOT research and staffing needs. Training materials that have already been developed contain over 24 hours of material that include topics ranging from statistics to hydrology to water quality. There are also 10 hours of class exercises to apply concepts discussed in the presentation. As part of this project, course materials and case studies will be further developed for adoption into college and university classroom curricula. Another goal is to connect interested faculty with these materials for use in the classroom. The SELDM project has a variety of available data and software tools. These include the Highway Runoff Database, which is a data warehouse and preprocessor for SELDM. The Kendall-Teal Robust Line software, or KTR line, produces transport curves of water quality constituents. There are 5 different streamflow data mining and analysis programs. And there is a SiteStorm database, which is a database with precipitation event statistics and rainfall runoff data. In addition, the project offers software tools and data for hydraulic and hydrograph analysis, as well as stochastic BMP performance analysis. The USGS, in cooperation with the Federal Highway Administration, developed the Highway Runoff Database as a data warehouse and preprocessor for SELDM. The latest version of the database includes over 55,000 event mean concentrations from over 4,000 storm events monitored at 118 study sites across the U.S. There are 17 new data sets that will soon be included. The current database includes data for 194 different highway runoff constituents. Constituents in the database include major ions, nutrients, metals, suspended sediment, and organic compounds. Many of the constituents have more than 1,000 samples. The Highway Runoff Database has an easy-to-use graphical user interface and can be used to obtain water quality pairs, water quality statistics, and other data. The database can be used to select paired water quality constituent values to do a regression analysis that will yield a dependent relationship. The database also facilitates the process for generating water quality statistics needed to model a random constituent. The KTR line program provides an easy-to-use graphical interface for developing random regression equations and comes with online tutorials. Examples of types of analyses include those for developing relationships between influent and effluent concentrations for stormwater BMPs, streamflow record extension, estimating runoff coefficients from imperviousness, estimating the average and standard deviation of logs of highway runoff concentrations, and also other applications that range from groundwater to climate change to human health applications. Once streamflow and water quality data are plotted, 1 or 2 segment regressions with flow are developed using KTR line. In this example, a 2-segment regression is most appropriate for the data. At low flows, suspended sediment concentrations appear to vary randomly with flows. At higher flows, suspended sediment appears to increase with flow, which is expected based on the ability of high flow to mobilize sediment from streambeds and banks. SELDM generates random storm flows and concentrations from a regression. If a more detailed estimate of pre-storm flows is desired, then 5 programs are available in USGS Open File Report 2008-1362 for obtaining and analyzing streamflow data. The GNWISQ program is designed to obtain data from the USGS National Water Information System website and to reformat it into a consistent format. The MKPP program reads the flow record and produces the probability percentiles needed to make flow duration curves, which are used to assess the characteristics of flow. The QStats program reads the flow record and calculates the necessary streamflow statistics. The SREF program provides the methods necessary to predict long-term flow statistics at sites with shorter records. The MKDF program creates batch input files for use with the US EPA DFlow program, which is used to calculate low flow statistics. The SiteStorm database is a database with precipitation event statistics and rainfall runoff data. Data for calculating individual runoff coefficients is available in the SiteStorm database and published with the Stormflow report. This database does not have a GUI, but has predefined queries for extracting data. The figure here shows a relational diagram of the database with the precipitation data and statistics and linked tables showing the relationships between them. The techniques, methods, and statistics used in SELDM are well reviewed and approved by the USGS and also the Federal Highway Administration. These methods and statistics are documented in 3 Federal Highway reports and 5 USGS reports. Applications of SELDM in New England and Oregon are also documented in a Transportation Research Record article and a USGS report respectively. You do not need to read all of these reports to use SELDM. In fact, most people that attend a 3-day training class can run SELDM within the first hour of instruction. However, these reviewed, approved, and published reports will support the use of SELDM for modeling potential effects of runoff if the model is challenged. The Federal Highway Administration and the USGS are currently cooperating to provide SELDM training materials for use in upper-level undergraduate and also graduate environmental engineering and science courses. SELDM course materials can be integrated into current hydrology or water quality modeling curricula or stand alone as its own course on stormwater runoff offered as an independent study or online. We are currently working on grants for curricula adoption. If you are interested in using SELDM in the classroom, please let us know by filling out a quick survey. Questions in the survey include, are you interested in adding a new stormwater class to your curricula or including new content to an existing class? If you are interested in adding new stormwater curricula, what forms of curriculum content would you be most interested in? If the USGS provided stormwater classes online, what types of students would you consider it for? And how much time or funding does it take to adopt a new class at your institution? Additionally, if you're interested in learning more about SELDM, please visit the website for more information on the model and also the educational outreach efforts.